this question, we have to solve the equation for solutions over the interval of 0 to 360 degrees. That is 2 sine theta plus 1 is cosec theta. Always remember that whenever we talk about a trigonometric equation, it's always a good idea if we can convert the complete equation in terms of just one trigonometric function. That is the best case. So we'll try that, and I think we can do this in this particular equation because using the reciprocal identity, we know that cosec is nothing but 1 over sine. So using the reciprocal identity, cosec is written as 1 over sine, and let's multiply by sine both sides. So we'll have 2 sine squared theta plus 1 plus sine theta is equal to 1. And if we subtract 1 both sides, we have 2 sine squared theta plus sine theta minus 1 is equal to 0. And this is a quadratic equation in terms of sign, definitely. So for the sake of simplicity, I'm going to make a temporary substitution of sine theta as y. So if I do that, we'll have a quadratic equation in terms of y, which seems pretty regular because we are used to solving quadratic equations. This can be factorized and can be written as 2y squared plus 2y minus y minus 1 is 0, which means that the factorization is 2y minus 1 times y plus 1. Clearly, from here there are two solutions, either 2y minus 1 is 0 or y plus 1 is 0. Now if 2y minus 1 is 0, which means that 2y is 1, which also means that y is 1 over 2, and from here the value of y is just minus 1. Now remember that the solution should be in between 0 and 360, and y is nothing but sine theta. So the value of we re-plug in y as sine theta. So sine theta is either 1 over 2 or sine theta is minus 1, which means that there are two solutions if sine is positive. It's quadrant 1 and quadrant 2. So in quadrant 1, sine inverse 1 over 2 is definitely 30 degrees. And in quadrant 2, that's going to be 180 minus reference angle, which is 30 degree. So this is 150 degrees. So these are the two solutions, and from here sine theta is -1 only between 0 and 360, only in one case when theta is 270 degrees. So these are the three solutions. Thank you.